Welcome to Mr. Barta's Notes. We're going to do a quick review at the beginning, and then we're going to get right into the new things that we're learning, which is physical properties of matter, and we're going to talk about some density things. So make sure you have a pencil in your hand, your journal's right next to you, your notes packet is right next to you, because you'll be filling in those things as we go. You're going to be doing some practice on your journal and in your notes, and you're also going to be checking out some videos along the way. So I'm going to try to make this as fun as possible. Just sit back and follow the directions as best as you possibly can. So during our review portion, I'm going to go very, very fast, and then when we get to our notes for the day, I'll slow down a little bit. If ever I go too fast, you can always remind me. You can always stop, write things down. Feel free to do that throughout this process, whenever you feel it's best or most needed. Okay, so let's review quickly. So dissolving is when we're going to take a solid solution and mix it with a liquid solution, and it's going to connect with those water molecules. All right, and those are some examples of dissolving things faster. Stirring something, providing heat to something. So heat, if it's a smaller particle, it's going to dissolve faster, and the larger the volume of water, the faster something is going to dissolve. Remember, just like Kool-Aid, if it's too strong at the beginning, you're going to put some more water in it to make it a little more tasteful. Same idea. These are things that obviously can't dissolve. Compression. So when we're blowing up a tire, when molecules and matter move closer together by force, so blowing up that tire in a bike, when you blow up the tire in a vehicle, when you're pumping air into a football, a basketball, you are compressing the molecules, moving them closer and closer together, so providing a force. And diffusion, when a movement of particles from a high concentration to a low concentration, just like a cologne or a perfume is in a liquid bottle, that's a high concentration. As soon as you spray it, it goes from a high concentration to a low concentration in the air. It becomes a gas, and then eventually moves throughout the room, diffuses throughout the room. So here's an example of diffusion in a liquid. So food coloring, drop it in, it dissolves into the water, diffuses into the water, sorry. And a movement of particles from a high concentration to a low concentration. And thermal expansion is when matter changes in volume because of heat normally, or the loss of heat. So this metal ball right here in that ring, it expanded, so it wasn't able to go through the ring, but when it cooled off, it was able to go through the ring. So that's thermal expansion, when those molecules move faster and faster, increasing vibration and often expanding that particular item. So let's get into our notes for today. So pencils in your hand, ready to go. What are physical properties of matter? Now you can follow along on pages 41 and 42 if you want. If not, if you want to write all these things down, that's okay with me. Whatever makes you most comfortable and most successful. So the characteristics of a substance that can be observed without, notice how it's capitalized in all caps, without changing the identity of the substance. So example of that would be if I took a piece of paper and I ripped it in half, it'd still be a piece of paper, right? If I took a ruler and I broke it in half, it'd still be a ruler, just wouldn't be an effective ruler for measuring anymore, but it'd still be a ruler, okay? So when things can physically change without changing the substance itself, like the paper is still going to be paper if I rip it, okay? Again, if I'm going too fast, you can always pause me and we can rewind and all that fun stuff. So make sure you're doing whatever it makes you successful as a student. So what are some examples of physical properties of matter? Basically, I like to use the phrase of use your senses, okay? So your smell, touch, taste, hearing, all of those are effective ways of determining if something has physical properties, okay? So color, shape, size, texture, all are a great example of detecting physical properties, okay? So the color, different layers are in here. Texture, so the sandpaper, and the volume, mass, temperature, density, molecular weight. We don't have to worry too much about molecular weight because that's a little more difficult, but these other 8 are extremely important for you to know. So examples of physical properties of matter, again found on page 41. Describe some of the physical properties of your desk. So here's where I want you to pause the video, and I want you to write down describing words of your desk, describing the feel, describing colors, shapes, sizes, anything you can do to create 6 qualitative observations about physical properties of your desk. Go. All right, welcome back. You should have 6 physical properties. Something that you could have written down had to do with the color of the desk, the shape of the desk, the size of the desk. Any of those things would work wonderfully. Okay, make sure you have all 6 of them though, folks. Okay, moving forward from that, physical properties are extremely important to have a base understanding of. Now we're going to move into density. All right, so density is on page 43 of your textbook. Density is explained best probably by how far apart the molecules are, or how condensed, how compacted are those molecules in your solid, liquid, or gas. Okay, so an example of that, it is the measure of the amount of matter present in a given volume of substance. So I'm gonna talk about this out loud. If I had a Diet Coke can and a Coke can, which of those things are going to be more dense? When I say more dense, which one of them is going to have more molecules in it? I want you to think about it. What is the difference between Diet Coke and Coke? All right? And I want you to determine before we go forward which one is more dense, which means it has more molecules in it, more mass, and which one is less dense, has less molecules and less mass. Okay? Think about that. And then moving forward, I want you to check out 2 things. First off, click on Study Jam's properties of matter. Your job during this portion is to play the video, and I want you to test yourself. Okay. After you've completed that, I want you to write down your score on your journal or your notes, whatever you want, whatever is more successful for you. You write that down. As soon as you've completed that, I want you to head back to your notes, and I want you to check out 5 facts about density. All right. So this is a really good video. This is probably one of my favorite videos for density because it describes what I was just discussing with you. So if we have a Diet Cola can and a Cola can, the Diet Cola can is going to float compared to the Cola can. Why is that? Okay, so here's a great visual of why that is the case. In the Cola can, we have a lot more molecules in the Cola can, tons of molecules compacted together. And in the Diet Cola can, we have less molecules. What is the main difference between Cola and Diet Cola? Well, during the video, it's going to ask you what's the main difference. And I want you to write down on your journal, what is the difference between a Diet Coke can and a Coke can, and why does one float and why the other one does not, or does float, sorry. Write it down. Pause the video. Write it down. Come back to me in 3. Okay. So after you've done listening, I want you to finish watching this video. It has some awesome examples or facts about density. Okay. Once you're done with that, I want you to come back to the notes and let's check out some examples. I want you to do some calculations. All right. So how do you find density? That's pretty easy. It's a formula, just like in math. Density equals mass divided by volume. Okay. So here's what that D equals M divided by V. This symbol right here is the divisible sign, dividing sign. So moving forward from here on out, I want you to make sure you know that. This link shows you how to use the formula and explains objects will sink or float. Please click on this video before we move forward. I want you to watch it before we're getting into density and making your own calculations. This does an excellent job of determining density of objects, okay? So in this example, we have a beaker, full beaker and an empty beaker, different densities because it has a different volume. All right. So in this example, they provide the formula for full beaker is 120 grams. The empty beaker is 20 grams. We're going to subtract 120 from 20, and we're going to get 100 grams. Okay, so density equals mass divided by volume. We have 100 grams of mass. We have 100 milliliters of volume. Density is then going to equal 1 gram divided by 1 milliliter. Okay, so 1 gram per milliliter. That's what this means. After you do a calculation, you say 1 gram per milliliter. So here's an example of density as well. So if something is going to sink or float is determined by its density. And I'll let you look through this video, but if it has a 0.1, notice that it's sitting on top of the water. If it has a 0.5, it's sitting kind of middle. If it's got a 0.9, it's almost ready to sink all the way down to the bottom. Okay, so 10% density, 50% density, 90% density. Like I said before, the amount of matter in an object determines how it's going to sink or float. All right, so head back to your notes and we're going to practice this. So make sure you have a calculator ready to go and a pencil in your hand. Your job is to determine the density of this following object. Okay, here's the volume. Here is the mass. So 0 plus 20, 20 plus 5, 25. So in my answer sheet, I should see density equals mass divided by volume, and then I want you to fill it in. So D equals 21 divided by 25. Type that in your calculator, 21 divided by 25, and I want you to put the answer at the bottom of the page. So density equals whatever the answer is, grams slash milliliters, grams per milliliter. Okay? Next one. I want you to do the same thing. Actually, let's pause. Let's go back. Make sure that you've completed these calculations before you go on to the next one. Okay? So you can pause my video, and we'll pick back up in a few seconds. Next one. What is the density of the following object that has a volume of 75 milliliters? Now, so it's still giving us the volume. Now we're trying to determine the mass. So 0 plus 60, 60 plus 8, 68. So density equals mass divided by volume. Density equals 68 divided by 75. Density equals, now if I'm going too fast for you folks, you can always pause me. Alright, density equals, and then put the calculation grams per milliliter at the bottom as well. Okay. Whoops, let's go back. And the final density, calculate it. So now we're going to see the density of an object that is going to be extremely dense. So it's probably not going to sink or float. Now, each of these it asks a question, will this object sink or float at the bottom? Remember, look back to that video and determine if it's going to sink or float. If it's going to sink, it's going to have a large density, probably over 1. If it's going to float, it's probably going to be less than 1. All right? So make sure you have that written at the bottom as well. So this object is going to be 100 plus 0 is 100. 100 plus 2 is 102. So density equals mass divided by volume. And this can be written in your journals, folks. Okay? We have density equals 102 divided by 50. And our density is going to be probably over 1. So that should determine if it's going to sink or float. Go back at the video if you don't understand. Rewatch that video again one more time. So that's our notes for today. I want you to be successful. So make sure that you are paying attention. If I went too fast, you can always remind me and check it out. Thank you for paying attention. I appreciate it. And keep working hard. You're doing awesome.